All right, before we go to the indication, I would like to also mention a few points which might come to a few of the viewers. For example, if I look at the main program, I have these two inputs here, okay, which doesn't look good because we are reading the data and now we are writing a function inside it. We could have also done that in the conveyor DB. We can also took these two inputs of forward and manual, and then we can basically have inputs in this DB instead of this DB. But this is just the way, this is a personal way of programming, you know. I prefer to do this calculation than SCL of this multiplication by 1, which makes it quite easy to understand, and this if and else statement. Because I was not using SCL in this logic, I did not use it. Or I can make a new function and call it in this function. So yeah, that is also possible. So let's try to do that way, because that also makes programming a bit clean. So what I will do is I will make a new function. This is just for viewers to understand how you can play around with the FB and FC, okay? Otherwise, this function will also work, which is already done before. So I will write here, okay, not this here, speed, no, not speed, direction control, and take it as SCL, click OK. And now in direction control, oh, sorry, I took FB. I should not take FB. I wanted to take FC. Add new plug, FC, direction control. This is SCL. Now if I go to the read function again, I will just cut these guys. And where is FC? And put it here. And now we have to define the forward and reverse, which I will do now. But if I go back to the read function again, I can take these two guys from here, cut, go to direction control, paste it here. Okay, so forward reverse are defined, there is no error anymore. And this FC now, so if I go to FB again, okay, now the function which I just made, this one, direction control with the forward reverse, I need to call it somewhere, and I don't want to call it in the main block, but I will call it in my this block, conveyor block. Now it is asking for forward and reverse, which I can give from here. So basically I split the function from the read function and made a new function and called it in the FB conveyor. Okay, so if I go back to read, there is nothing here, and if I go back to main, you will see if I update this block, I don't have to give any inputs to that. I'm not giving any inputs here as well. So this clean blocks looks very nice. Reading the inputs, conveyor logic, writing the outputs. And in the conveyor logic, I have defined these inputs. So this will also work, okay? Because in the end, we are just writing the values to input our speed, which is the data block here. So there is no output here, okay? All right. Now comes to the indication part. Okay, just to make sure, I will just download it and try so that you are assured that this logic will also work. So as I said, there could be multiple ways to program it. You can do it in 10 different ways and get the same results. So it's up to you in which area you find yourself more comfortable. So go back again and I will try. Okay, this is already running. I didn't notice. So now it is running in forward. This is positive 10. Now it in reverse. Okay, this is what we need to check it. Going to stop it now. And now we need to make indication. Now for the indication, again, it's how you want to use these indicators, but I will use the most general way. So if the motor is running, we will use green indication. And when the motor is not running, we will turn off this indication, okay? I will not use orange or yellow here because we don't have a manual mode. We generally use this for the manual mode or the maintenance mode, which is more or less like a manual mode. And I will use red indication just on and off in case if there is any error, and this red will blink if I press e-stop, because blinking needs some, it's a more alarming signal. So because blink gets your attention, maybe not red, but when something's blinking, it means, hey, come on, look at me, something is wrong. But it's up to you. You can also use blinking for the error, but just to have some diversity in the blinking or in the stack light, I'm going to use just on and off for the error, blinking for e-stop, and this on when the motor is running. And we have two more indicators here, forward and reverse. when the motor is forward, this will be on. If it's reverse, this will be on. So we understand how we need to use our indicators. All right, so let's go back to the programming. Now it's up to you. Okay, let's first of all give the names. This is start stop logic. Okay, this is speed control logic, and this one is direction control. I would prefer to put direction control above speed control, because direction control is basically giving the value to the speed, this one. So this output is going to this one. So I prefer this direction should be above the speed. Okay, so how I can do that? I can just drag this network and make it like this. So direction is first, start, stop, and that direction, and then the speed. And network 4, we can use indicators. Okay, now it's only up to you if you want to make the indicator logic like here, like I have made here, or you can also make a function of just for the indication, and you can call it in this FB. It's totally up to you, but just to make it more simpler, I will prefer to design it here. Okay, what do we have? We have first of all the start logic. So start stop logic we know is controlled by a start bit. So I will use the start bit to use a green indicator. So I will take an AND logic. So if this bit is on, I will remove this one. My green indicator should be on. So my green indicator, okay, we haven't took the stack light. Oh, another work. Okay, let's go back to the drivers again, and we have stack light red to 2, yellow I'm not using it, so let's take green. So red is 2, green is 3. So going back here, and immediately, you know that we go to the tags. So here Q, X, red, which was 5. Was it 5? I don't remember. Red is 2. Oh, this should be Q 0.2. Oh, 2 is for the error. Wait a second. Oh, we removed the error. So delete this one from here. We don't need error. Red is 2, and Q underscore X green is 3. Let me check again. Yeah, green is 3. All right, so tags are defined. Now we need to write these tags. Okay, so we don't use error anymore. We don't need error, because error, we remove the LED, and now we're using stack light. So in this guy, in this data block, again, we don't need error. So I will replace error with red, and I need one green. So Q underscore X green. Perfect. So you know what we need to do. Take red here. Oh, wait a second. Not in the right. This will come in later. Let's go to the PLC tag, because we are writing the tags. Okay, so red, let's take here. Green will come here. Quickly assigning it. Close the tag table. Oops, where do you go? Right, and the red will read from the data block. Closing it. Green as well from the data block. Closing it. So our write outputs are defined, so these will be written to the PLC tag. So we don't have to deal with the PLC tag anymore. So start bit has to turn on the green. So just take green here. Okay, to take the green here, we need to take assignment block, and you take green here. So when start bit is on, green is on. Start is on when the start button is pressed, motor is running, so green is on. If motor is not running, green will be off. That's what we need. Okay, now coming to the error. So if we have any error, so for the error, I will just prefer to copy paste it, and here we don't have start bit anymore. So here is the error, and the error common I would prefer to take. Error common, this is going to make red on. Red indicator, Q red is on. This is the one way. Now there is another way how red will be on. Red will also be on, or it will blink if we have an E stop pressed. Okay, so when e-stop is pressed, red will be blinking, and this is the output for the red. So what we can do is we can have another input for the red. So basically we'll just try to move it up. Okay, so I will take here, we need to take another AND block, and here I will take e-stop input. Now e-stop is normally true, so I will take here NC. Okay, so when e-stop is false, this block will be true. And one more thing, we need to blink it. Now to blink the outputs, there are two ways. One is you directly use the clock pulses of PLC, which I really prefer. Otherwise you define by a timer if you have specific blinking time. But I will prefer to use the clock pulses from the PLC. So if you have defined it or not, you can check it. So go to the properties, system and clock memory. So we have defined it. So you can see that here we have this clock. So we can take 1 Hertz clock, which is fine. So M0.5 is my pulsating bit, M0.5. I have to remember it. So here I will write M0.5. So this is my pulsating. Well, let me check again if it has some comments with it. M055, oh, this is tag 1. We can write a tag to it just to make it looking more nice. So this is M0.5. So we can write X clock 1 Hertz. Okay, so you can define the tag here so that you can understand what's going on in the programming. So you have 1 Hertz clock pulse. This will go, wait a second, this was the error com. Okay, I should hit right here. So this will go along with e-stop, so which is here. Why did I took it here? Okay, this will be NC and this will go. Yeah, so when e-stop is pressed, then blinking, they both go to the AND gate, and this should in the end should go here. Wait a second, I will put here assignment. And this would be basically OR gate. So red will be on. If error com is on, this will directly turn on the red. If error is not on, or if e-stop is on, this will go with the blinking and turn on the red. Okay, we can try that. So we have the logic for the green. When motor is on, green is on. When motor is off, green is off. We have defined it for the error, and we have also defined for the e-stop. What is left? The thing which is left is a direction. Okay, now direction is quite simple. We will just take an AND gate and remove this guy here. Now if your input is forward, your forward indicator is on. Q, this one. Okay, I need assignment. Delete this guy. Similarly for the reverse, copy paste. If it's reverse indicator will be on. Okay, not this one, this one. Okay, so great, let's try this. Download to the logic. Reinitialize the data. Okay, it's loaded, almost there. Let's check the instructions now. Okay, pretty nice. Now you can see that this is at reverse. Good. This is forward, reverse. Nothing is in the stack line because motor is not running. Let's run the motor. This is running in reverse now. Let's check. The speed is being controlled, or we have to display the speed. No problem, we'll do that. Now this is running forward. You can see here it's forward. Great. Now we need to check our e-stop. So I will stop it and I press e-stop. In this case, you can see it's blinking. From the far distance, it can be easily monitored. And if I release it, it will be stopped because e-stop is released. Again, it's blinking. and then it's stop, and I can start the motor. And if the motor is running and I press e-stop, you will notice it will blink and the motor will be stopped. Okay, so let's check for the error, because I don't have error defined here, so I will simulate the error. So the motor is running in forward, and I go back here and I have error COM. So I will make it true. In this case, you can see that red is on, motor is stopped, motor is not running anymore. And if I go back and make it false, okay, one more thing, if you just want to check, I cannot start the motor because there is an error. So when I remove the error, make it 0, this red indication is off and motor can run again. I hope this makes sense. Now very quickly, let's move the speed into the speed indication. Now for that, you notice that in this case, oh, I have some constraint here. This is showing the value from 0 to 10 volt. Okay, if you're okay with displaying 0 to 10 volt, that's fine for me, but it can also display -10 to +10. But what we want from -100 to +100, because we prefer to see the speed in percentage. So we have to take integer. Okay, we have to take integer. Now in this integer, our actual value, if you notice in the parameter, is from 0 to 100, and for forward, where is that? Here, and 0 to 10 for forward, 0 to -10 for reverse. But we need from 0 to 100 and 0 to -100. So the gain is of 10. Okay, so we can just make it in the indication, but I actually prefer such kind of calculations in the SCL, but nevertheless, we can make it here as well. So we will read from the parameter DB, where is that? Oh, parameter here, we will read from here. So let's take some instructions. So here, all right, wait a second. Our final reading is not coming in parameter. This is coming here, IR speed, which is also getting the value in minus. So it's better to read it there. So for example, if I make it minus, reverse. Oh, I need to download the logic. Oh, wait a second. Oh, maybe I remove this. Go to -5/2. And you can see that speed is coming here in minus. Output is also minus. Well, you can also read this, or you can read this. So it's also better to read the output. Now, but we will not read the parameter because this is in positive. We cannot display if we use this one. Okay, so here, coming back here. So let's take genuinely the output. So we have the output now. Now we need to, okay, let's not do this. We need to convert this real into integer. Okay, so basically you need to convert it. So you see the conversion program here and convert value. Let's see if we can do that. This is convert real into integer, and here the output is this one. And we have to change this to integer. It should be double integer. I need to check to my here. If I use this integer, what do I get here? Yeah, it's a double integer. No, wait, it's roller conveyor and display. Yeah, this is double integer. QD204 is my double integer. And let's change this name. Speed in percentage. Okay. So I have to remember this is my double integer, and if I see my, again, tags, let me just check, speed indication is fine. And we are writing the information also. Here I need to make it double. This is double integer. So double integer is here, speed indicator is going to, these both are double integers. That's perfectly fine. So going back here, let me see if I have double int. Yes, I do have double int. So real is converted into double int going to the indication. This you need to do if you have different types of data types involved in reading and writing. Okay, so conversion is quite easy. Just take the function from here and you can convert it. So let's just try if this works. Loading configuration. Everything looks okay. I need to make sure if this is working. You can see that this is -5 here. Okay, so if this is -5 here, we should read. Okay, this has some problems. This guy has some problem. It read integer, but it is giving some random values. Okay, I cannot help with that because normally it should work, because we can see that the speed indicator is coming here 3, and if we just link this 3, let me see that here, what's happening. Call environment main line conveyor db online, and let's see, oh, it's getting 3. So this is not the programming fault, because we know this is dint here, and if we see here, this is also double int here. So this is a software bug, I would say, because this should exactly reading the value from the PLC, but it's not my fault. So what we're gonna do is we can ignore this part, but you know that the readings will come because we have done that in our programming. So this is the speed indicator right now in positive, and if we have in negative, this will be -6. So if you see speed in negative, I can see the negative, but not the exact numbers, which means our speed is running in anti-clockwise direction. If you really want to see it in minus, if you just want to see in positive, that's okay for me. You can just remove this minus thing here and just read it directly from the parameters. So it's totally up to you how you define the documentation of your panel, that if you want to display it in minus or positive, that's totally up to you. But I hope in this lesson you have understood how to use indicators and how to use basic programming instruction in different DBs and using FB and FC. So if I just want to conclude this logic, so let's go to the main logic. We have initially the read function. So this read function is reading the inputs from the PLC and moving it into a data block, which is defined for conveyor. So initially was the read function. Then we have the main logic. Using the read function, we are writing the outputs. And the good thing is we are writing the outputs in the data block, again into this data block, because this data block has inputs and it has outputs. So we are writing the values in the data block. You can see that this data block are going directly here, and this indications are also going here. All right. Now, what is happening next in the main logic? We are now writing the values. So whatever values we have written in the output in the data block are moving back to the PLC tag. So read function was reading from PLC tag to the data block, and this FB solving the logic, moving the value into the data block, and then the output go back to the PLC tag. So this is exactly what we have discussed before. So if I open my logic for this, okay, I need to see where we have defined it. Yeah, here. The main OB has DB in out, which is reading the PLC tag input, solving the logic, giving the output to the PLC tag, and this is going to the field. So first we are reading from the field sensors via PLC tag, go to the DB in out, solving the logic in the main block, and then the output goes back to PLC tag outputs, going back to the actuator. That's how it is working. And this is quite flexible way of programming, because this is a very small example. In the further videos, I will show you if we have two of these conveyors, two conveyor system, how easy it is to take care of the programming if we have structured way like this. All right, that we will see in the further videos. Thank you for watching.